Hello, happy Maga! Welcome to this module CM3291, Isolation of Eugenol from cloves using steam distillation. I'm a lecturer Funman, and I've moved to my new office. This is at block MD1, level 5, room 3D. So you gotta give me a call when you reach here so I can open the door for you. Now the objective for this experiment is, number 1, to isolate the clove oil from cloves by steam distillation and extraction. And number 2, we need to characterize the product using spectroscopic techniques. Now the outline for this lecture, I'll first of all go through review the introduction, followed by the procedure, overview, and next we'll go on to analysis. And you notice here I give you this recommended text for CM3291, especially for this particular experiment. I think it's very important for you to do some little research on organic spectroscopy. This book by Joseph B. Lambert and the rest is a very new book, come out in 2012, really useful. It's better for you to read up. If you have time, please go ahead and learn. Now for the introduction, we know that simple and fractional distillations are carried out on what kind of mixtures? Is it immiscible mixture or miscible mixture? That's right, miscible mixture. That means, right, the liquid that will come together to form one homogeneous solution. We learned that ideal mixtures follow the Raoult's law. Recall Raoult's law from your physical chemistry. Raoult's law states that the total vapor pressure of the system is determined by adding together the product of the vapor pressure and the respective mole fraction of the compound. So for the two compound system, this relationship is shown in equation 1. Over here, where you see the PT is the total vapor pressure, the P10 and P20 are the vapor pressures of the pure compounds 1 and 2, and the X1 and X2 are the respective mole fraction. Distillation can also be performed on mixtures in which the two compounds are not miscible, right? Immiscible liquids. So they will form heterogeneous mixture. Now this process is called co-distillation. Remember, we are now applying distillation on immiscible liquid, and we call this co-distillation. And when one of these compounds is water, we call this process steam distillation. When the two immiscible liquids are distilled, the total vapor pressure PT of the liquid is equal to the sum of the vapor pressure of each compound. Now this relationship, which is termed by the Dalton's law, is shown in this equation 2, and you found that the respective mole fraction are not included in this equation. And why? Isn't that very funny? It is because in an ideal situation, each liquid vaporizes independently of the other. So when PT is equal to the atmospheric pressure of 760 torr, torr is unit for pressure, stands for Torricelli. Now the compounds 1 and 2 will begin to co-distill, with each compound contributing to the PT. That means they will distill independently on their own, no effect on each other. Now for instance, consider water as compound 1. So the vapor pressure of pure water at its boiling point is 100 degrees Celsius at 760 torr. Now because compound 2 is also contributing to the total pressure PT, so the mixture will still distill at a temperature less than 100 degrees Celsius. Now the actual distillation temperature will depend really on the vapor pressure of compound 2, the second compound that you added to the water. And steam distillation offers a couple of advantages. Two of them especially I want to highlight. Number 1, it is that the volatile compounds that are unstable or have a higher boiling point that can co-distill with water at relatively low temperatures. This process avoid decomposition that might occur at the boiling point, normal boiling point of this compound of interest. So basically it's like, if I spam a lot of heat at this compound, right, it will just split into some other various compounds, products that we do not want. But with this process, the heating is a bit more gradual. It will first be converted into steam, the vapor phase, and then after that you can get back the original compound intact. You won't be decomposing it, breaking the covalent bonds or so whatsoever. And the second advantage for this is you can also avoid the decomposition that might occur at the normal boiling point of the compound of interest. So once again, the two advantages of steam distillation is the volatile compounds that are unstable or have a higher boiling point can co-distill with water relatively at a low temperature. So it comes out together with water. And the second advantage is you can avoid the decomposition that might occur at the normal boiling point of the compound of interest. Because now you're changing it from a liquid to a steam first, right? That's not breaking any covalent bond because it's just a physical reaction. Then you can collect your pure compound by condensing it back to liquid state. Okay, so it's very useful, steam distillation. It is your first time, might be the last time doing this, so do it once, do it well. Now in general, there are two methods of steam distillation. Number one, it is we are using excess amount of water to the compound of interest, in this case clove oil, and we put it into a distillating flask. So here we're using a flat bottom flask. Now then the mixture is being heated to the boiling point, and then we collect the vapor, which is then condensed, and we get the liquid. And then the compound of interest will be separated by water, and normally we use extraction in this case. Now the second method is, as the word suggests, steam, right? Steam distillation. So we could also insert steam via bubbling into our compound of interest, and we can cause the distillation to occur. Notice? But in this case, think about why we do not use the second method, why we use the first method. Always think about safety, that's number one. And number two, the first method is more efficient, it's easier to be set up, because now if you're dealing with steam, right, it is not too easy. Steam, gases of hot air coming through you, it is a gas and it's a bit harder to control, and moreover, it could be a bit too addictive for some of you. Now, essential oil have been used for centuries as perfumes, medicines, flavorings. They are derived from plant sources and are most commonly isolated by steam distillation or extraction of the seeds and flowers of plants. Now, some essential oils contain a complex mixture of terpenes. However, most spices like caraway, cinnamon, and fennel, they yield relatively pure compounds. Now, this is a picture that shows you the lavender field that's found in France, on Provence. We extract essential oil from here, sold quite expensively in the L'Occitane, but it smells really good, and you have some medical effect that can soothe your emotion. Now, clove oil is again one of the essential oil that you can find in the market. It belongs to a large class of natural product. Why do we call it essential oil? Have you thought about the history of it? It is because it came from the essence of the plant that we extract it from, we derive it from. And cloves, if you speak Thai, you know it is called Kanpu. Are the dried flower buds of the clove tree, Eugenia caryophyllata, that's found in India or other locations in the Far East. Eugenol is the major compound, which is about 85 to 90%, and eugenol acetate worth 9 to 10%. So for these structures, I would like you to, as part of your homework, research and know how to draw them. Alright, not sure, get back to me. Next, safety precautions. Supremely important to you. I need to read out to you. You have to read it again and again. Do not think that because clove oil is used as a form of essential oil onto the body, then it is really safe. Like oil, it is flammable, right? It can cause irritation, it's a form of chemical. So clove oil may cause irritation in case of skin or especially eye contact or inhalation. Some of us, even though we have fragrance, right, from some brands, but we do not like it because it just doesn't suit our flavor. Yeah, so it doesn't mean all perfume smells good to you, or though the toilet smells fragrant. Same for clove oil. It's a kind of spice, fragrant, may not be our liking. So if you know that you're allergic to cloves, please let the TA, let myself know, let the lab instructor know. Later on, you'll be using ethyl acetate to extract the clove oil, and this is flammable, so you've got to perform all operations in a well-ventilated fume cupboard. Please refer to the SDS. I've uploaded it online on the IVLE, the safety data sheet of the chemicals used for detailed safety information. Good information to know will be boiling point, melting point, flash point, the appearance, density. At least know these. Now next I'll be covering the procedure. Please have ready your lab manual with you. Now step 1, you're going to crush 10 grams of whole cloves using the mortar and pestle and add to a 250 ml flat bottom flask along with a flat magnetic stirrer and 60 ml of water. Allow the clove to soak for 50 minutes. 10 grams we stated. Can you add 11 grams? Can you add 9 grams? What do you think? Do we have enough clove oil from the 10 grams of clove? Now you notice that some of the mortar and pestle, right, they come in different sizes. You may find that 10 grams could be a bit too excessive for just one kind of grind. It may spill out. So one way you can counter this problem is you can use a hand to cover the most of the top exposed area of the mortar and pestle, and after that you grind this way, so nothing jump out. Yeah. On the other hand, you can also split into smaller fractions, maybe 3 grams, 4 grams, and then you do it partially, then batch by batch, and then combine together in the end. I'm fine with you, whichever way you like. Next thing is, why do we use a flat bottom flask? You can see from a slide that later on I will tell you a bit more. It's for better contact between the heating mantle and this flask. Now please use the right magnetic stirrer. It should be flat because now we're using a flat bottom flask. If it's not flat, you're using a round bottom flask, then it will not be effective in spinning the heterogeneous mixture and cause it to react in a more proportional manner. You have to leave the glove to soak for 15 minutes to allow a physical process called diffusion. Maybe some of these oil or whichever substance can be released into the solvent here, even though it might be slightly immiscible or insoluble, but it doesn't matter. You allow time for them to equilibrate for a while before you apply the heat. It is really useful. You just think about your auntie, your mom, or anybody in your home, yourself being the cook, and then you always soak the piece of meat, right, or veggie into the water first before you start to cook the sauce. Yeah, you leave it for some time for them to seep in to the solid before the effect takes place. Then we assemble a direct steam distillation setup as shown in this picture here. Now you're going to make sure that the flask is placed in full contact, flat bottom flask, right? So it's really flat, no gap between the heating mantle and the flask. Okay? Do not just secure tightly the boss head of the retort stand and then make sure okay it's ready, but then you got to check again, level your eye at the bottom of the flat bottom flask and see there's really no gap. So you should really place the flat bottom flask first, make it settle, and then slowly secure the boss head. Not adjust boss head and then force it down and then thinking that it is all in full contact. It may take you more than 3 hours, then you can't finish. Next, we connect the water tubings to the Liebig condenser. Liebig condenser we'll be using here for the condensation of the vapor. Now I'd like to highlight this point here. There are actually 2 main kinds of condenser that we have in the lab. If you don't have the Liebig, what can you use? Oh, by the way, what is a Liebig condenser? Or is there any difference between a Liebig condenser and a Graham condenser? For a Liebig condenser, you see that water will go in to the condenser and surround the main internal tubing. Whereas for a Graham condenser, we have many small channels that go through the internal part of the condenser, so we allow for a larger surface area for the condensation to occur. So the Graham condenser is a bit more effective and efficient compared to the liquid condenser. In this reaction, we are doing a simple physical process where we change the gaseous state to the liquid state. So both are fine. But if you go to do some higher order research and you'll be using something really expensive and super small milliscale, then I would suggest maybe you can use the Graham condenser, because you do not want any of your compound to just vaporize and gone out of the whole reaction setup. You want it to be refluxed, going up and down, right? We don't want it to escape to the environment and it's all gone. $1,000. Wow. Vanish in thin air. Now the next part, you need to set a high setting, about 300 degrees Celsius. So this time you could, I see some of you did that, spam to the highest end of the scale of the heater. This is fine, but then if you could spare some time, adjust slowly and see the gradual change. You can also record a small GIF or, I don't know, Snapchat, you use this, and then you see gradually the heating process is really wonderful. You see that it stirs, right? Like a whirlwind, and then the color change a bit, and then see bubbles coming out. You get some kind of emulsion here and there. I shan't tell you more. You can experience yourself, record down all these observations, right? You need to heat it up so that this water mixture will start to boil after some time. And again, monitor the system as the product, right, may foam over. Why is there foam? Foam. Air bubbles, a lot of bubbles coming out. What will foam? Can water foam? Can aqueous substance foam? Or only with some oil involved then it foams? Just think about when you visit the washroom, okay, and you pass off some urine. Sometimes it foams, sometimes it doesn't. What is causing it? So I actually tried some experiment, and one night I had a very heavily fat diet, okay, something very oily, and the next morning when I went to the toilet and discard my liquid waste, notice that there's a lot of bubbles. So it tells me that when you have a very oily diet and overnight the body will tend to pass out this oily substance, the waste, and then you cause it to form bubbles. You can try if you have a day with minimum oil, then you don't see foams. Experiments, right? Home experiments, it does no harm. So you see, this is life teaching you to be a bit more curious, to find out things that you observe every day that you do not question. Okay, so as the reaction progresses, you also need to collect your product, about 15 to 20 ml of the cloudy suspension that contain your clove oil in water. Take note, what you collect here, it is not pure. It is a mixture of clove oil in water. It might take up to 2 hours, but it could be as short as half an hour, or if you're lucky, or you may call unlucky, split second, maybe 15 minutes. You just have to observe. You can't depend on what we tell you, because the condition will change. The temperature change, the atmosphere vary a bit, and our skills are different, okay? Like for me, I do not use handphone at all when I'm working in the lab, but I see most of you guys always turn to Instagram or other applications, Facebook or any good read, then you get distracted, and I don't know, just saying, stay focused. You have to add water via the steel head on top, pull out the thermometer adapter, and add carefully. Because steam is boiling, it's really hot, can burn your skin. Always wear glove, PPE, goggles, lab coat. Now you will only add water to it if, and only if, there's a need to keep the glove surrounded by boiling water. So that means if you have water surrounding the glove, it is fine. But let's say it is drying up, then you could add a bit more water. Top up. At the end of the day, how do you dispose the gloves? Solid, right? Brown solid suspension. Do we dispose it in the waste bin, trash bin, or what? You should transfer it, in this picture shown, through the strainer that we place it in the basin, so that we collect the solid and then we discuss it later on by the custodian of the lab. Now there are two techniques again we need to revise with you here: liquid extraction, drying agent. Right, you have done this many times in your year 1, year 2, maybe even year 3 before this, but there's no harm going through again. Revision for you. Okay, hope you have seen this video again to see what is the proper procedure, the action you got to take when you are conducting this kind of procedure. Ooh. Now for the extraction of essential oil, the next part of the steps in this experiment, you have to add 10 ml of the EA to the distillate to dissolve the essential oil, and then transfer the mixture to a separatory funnel for extraction. Some people ask, oh, I accidentally added more than 10 ml, 15, is it okay? Just think about it. What is it used for? It is for the collection to draw the oil from the suspension of clove oil and water to the organic phase. So the more you have, it can be disadvantage or could be some merit. It depends. Later on, you may need to do 2 or 3 times rotavap to evaporate all the organic solvent, but it doesn't really significantly change your compound integrity and whatsoever. So please fret not. Next, you separate the 2 layers in the separation funnel, return the aqueous layer to the separation funnel again, and extract again 2 more times with 15 ml of EA, the same solvent we keep out constant throughout. 2 more times. You have learned in CM1191 that 2-3 times is the best, is the optimal number of times you extract from the separation funnel to get your compound. But of course, the more you do, the merrier it is if you have time to spare. But it will go down in terms of the efficiency. So not that necessary. Next, then you combine these organic layers and wash it with 10 ml of brine, concentrated sodium chloride. Think about why we added this. Okay. Next, we then dry the organic layer over the anhydrous sodium sulfate, filter the solution through a pre-weigh and dry 100 ml RBF round bottom flask. Then we remove the solvent using the rotavap. Many students always forget to pre-weigh it, so they added it, forgot to weigh, and then trouble. They need to wash everything up first, wait for it to dry in the oven. It takes them an extra 1.5 hours. They're gonna have a bad day. Don't. Please always weigh your dry RBF. Put it on the marker, on your lab manual, on anywhere. Okay, can write on your hand, on your glove. Please just record it down. And then after we dry it using rotavap, we collect it, and we notice that the EA would like to stay inside the RBF, so you will not evacuate all the EA just by the rotavap. You have to connect it to the vacuum line in your own fume hood to get rid of any trace EA that's there. Trust me, look at this picture, it will show you how to do it. Yeah, just connect, make sure it's all tight, being careful. The black tubing goes in, rotate it in to the joint, and then turn on the vacuum. And then finally, you're going to calculate the amount of essential oil obtained and submit the sample for NMR analysis. Just a proton will do, and you add 1 drop. Just 1 drop. Do not add 5 drops. It's too much. When it's too concentrated, the people downstairs, the lab technicians at the NMR lab, they will have a hard time getting a very good spectrum for you. So help them, help yourself. Just 1 drop will do for liquid sample. For solubility and liquid extraction, just a bit of reminder. Now this involves the distribution of a compound between 2 solvents that are immiscible in each other, and typically we use one of them as water, the aqueous phase. Just like in this experiment, we use water and, recall, DCM? No, ethyl acetate. So some of these organic solvents are listed here: diethyl ether, DE, EA, DCM. Yeah. All these are immiscible in water, even though if you draw out their own molecule, right, they have their own dipole moment. So people always get confused. You know, it is not symmetrical. So it is actually having some kind of net dipole moment, but how come it doesn't dissolve in water? Because the overall interaction when the 2 liquid mix is not able to overcome the internal van der Waals forces of attraction or whatever other kind of intermolecular forces that's holding the pure solvents together. So this is a bit about physical chemistry. You compare before and after. Is there any loss in energy of the system? If yes, they will form a homogeneous mixture. If not, they will not combine. They just form 2 different mixture. Solvents that are miscible with water, acetone, methanol, ethanol, because all of these can form hydrogen bond with water. Do not be tricked if somebody asks you, in a separatory funnel, right? When I add acetone with water, 2 layers, no? And then which is the top, which is the bottom? Just 1 layer will do. So how do you check which is top and bottom? You have to check the density. Density tells you. High density at the bottom, it will sink. Again, some other mistakes that's committed by your classmates. I've seen over the years is they tend to pour the reaction mixture into separation funnel, but they forgot to close the, we don't call it the tab, but the stopcock. Okay, stopcock. They forgot to close it, and then they wash it down, all gone. They can't collect it. They can only use the paper towel and then try to squeeze it in. It's very nasty. So please always check, make sure all the stopcock is sealed, is tight, nothing's leaking first. Test it out before you conduct this liquid extraction. Okay. Another mistake that I see is they try to drain the separation funnel with a stopper still in. So they shake it, right, extract, and then stopper is on top, and then they try to open the stopcock and drain, but then it is not moving. So they shake it, without realizing that the top is sealing it, creating a mini vacuum. So you need to open the stopper and then turn the stopcock, allow the liquid to flow down. So you are now year 3, you should be pro, because of last 2 years you were maybe newbie. Yeah, practice a bit more, be more confident. And the last mistake they make is they drain the top layer through the stopcock. So remember, 2 layers, bottom comes up from the bottom, top comes up from the top. Don't mix them up. Don't do it just for convenience. And next we could use drying agent, right? So again, what's drying agent? We have done Viva before, Viva Voce to students, and they couldn't answer some examples. Organic layer, after we collect, right, there could be some remnants of water that's hidden inside there, and we need to dry it. So the drying agent's job is the anhydrous is an anhydrous inorganic salt that acquires water when exposed to moist air or wet solution. So the equation here, I'm just using a sample of sodium sulfate. We have a wet solution. It will form the hydrates of the salt, okay, and then leaving behind the dry solution. This dry solution, what I mean is solution using solvent like DCM or ethyl acetate, dry, free of moisture. Okay, so this is anhydrous, and that is hydrated sodium sulfate. Example here. Common drying agent used: sodium sulfate, magnesium sulfate, calcium chloride. So check the label that you are adding in, because each lab we can give you all 3, so it's different. So you check and see which one you used. Put it down in your lab report and tell us. How much to add? Add until your liquid move freely. Okay, your powder that you just added move freely. That means it doesn't form extra lumps. If additional drying agents added, they form lumps, right? That means they're aggregating the moisture, and it's still not dry yet. So you add a bit, you see whether the newly added drying agent is flowing freely in grains, small grains, then you know it's dry. After that, remove it by gravity filtration. Still hope you remember how to fold a fluted filter paper. Practice. For this experiment, the analysis and discussion not too convoluted. Just in the NMR spectra, identify the signals that belong to eugenol, the main extract from this essential oil, and also identify for us the signal that belongs solely to acetyl eugenol. Acetyl eugenol, we talked to you about it just now, eugenol acetate. Yeah, it's an ester. Try to draw the structure of these two. Find out, get the right thing. Next question is, think about how will you use extraction to obtain pure eugenol from a mixture of essential oil collected. How to do it? Just brainstorm, you can talk to your friends. And lastly, record what you see, what you hear, what you feel, all your thoughts and reflections regarding experiment. It's more like a diary, like a journal, life journal, or diary, like record what you have done, and then what's my mood, how do I feel, what happened. Always stay focused on experiments in the lab. Remember that while we cannot predict the outcome of the results, whatever your result, product, yield, purity or what, but if you do the right thing, stay focused, do not get distracted, we can control this, right? And also recall and also tell yourself that it is really a privilege, it is an honor to be working in the lab. There are people There are people from other majors, other courses, they want to work in the chemistry lab because it's so fun, but they have no chance. But you guys, you are the privileged lot, so be thankful. Alright, enjoy yourself, be safe, talk to me if you're not sure. Have a good day, I'll see you.
素晴らしいちんちんもの金玉の亀あるそれの音サルボボいえ忍者がいます